All right, so I'm going to try this format because it allows me to tell you what I'm thinking as I'm doing it, and rather annotating, because if I annotate an hour and a half paper, I'm not going to remember what I'm thinking at the time. So I'm just going to have to do it this way, even though it's a lot slower. So let's start. So question 1, identify a class of compounds that belongs to A over here. Now, this is a pretty easy question because they give you so many options, so it's pretty obvious that we've got oxidation of alcohols here. So carboxylic acid, aldehyde, alcohol. So and then alcohol by carboxylic acid. It's just really obvious, okay? And so because that has gone to a butanoic acid, it must be butanol. So butan 1-ol is what I prefer. They're both UPAC names. So if you look in the mark scheme, it'll have butanol or 1-butanol. Butan 1-ol is quite fine as a UPAC. There are alternate UPAC names. So what we have here is the structural formula. C is an isomer of compound A. Deduce the names compounds A and C. So we've got A and C over here. So what we've got is we've had, oops, it's not asking for that one right there. It's butan 1-ol. But what we'll have is a butanol here. And so then it's got a H2SO4 turned into an alkene. So that must form here. And then the addition of water into that must be Markovnikov's rule. And so the OH will preferably go over to this one here. All right. So it's got compound C is an isomer of compound A. So it could either be A or C for that. Sorry, this one says compound A here. So we know that that one must be over there. So that one must be the butanol. All right. And so we'll just draw that one out. Make sure you draw all the hydrogens out there as well. And that's fine for butanol, butan 1-ol. All right, now when you go to the next question, you have to flip back and forth. But what you'll have here is compound C. Must be the one that's on the inside, and so this time it's over here. So just make sure you've drawn in the correct number of hydrogens for each. And as I said, I prefer to put the ol in between there. Okay, so identify which compounds A and C are structural geometric isomers. I have that one on my sheet. It's structural. You just have to know the geometric will just be rearranging around. It'll say the same functional groups, but you can just twist and turn it or whatever. So the structural is what you're after. Now, compound F, if you go back to here, compound F's over here. So you've got the F here as the stem, and you've got the but as the end. So it'll be, so we can draw the but over here, and the O and the H will come out as H2O. So the H comes off here. And the stem is the ethanoic acid. And so that ethanoic acid, the OH comes out there, and the H of the other comes up over there. So that is eth. So make sure you've got the correct number of hydrogens on there. So it'll be ethanoate. So butyl, ethanoate. All right, so that's an easy one to start with. All right. Okay, so this one here, deduce if the forward reaction is exo or endothermic. So this is the contact process, temperature increases and the Kc decreases. Okay, so the Kc is products over reactants. So if temperature increases and Kc decreases, this must mean decrease in products, increase reactants, products, reactants. So therefore, we got reactants going to products. We've got a decrease in the products, we've got an increase in the reactants. Therefore, heat energy must be on the, so if we're decreasing the energy, must be here, must be on the left hand side. So this is energy. So we decrease the energy, that decreases the products and increases the reactants. Therefore, process is Kc decreases, products over reactants. Oh, temperature's increasing. Oops, temperature's not decreasing. Temperature's increasing. So if the temperature temperature increases, this Kc decreases. So temperature is increasing, so it's actually the opposite. Temperature increases, pushes the reaction over here. Still pushes it to the left-hand side. This one increases, products turn into reactants. Okay, so if the temperature increases, the Kc decreases. That must mean it's the same thing. Decrease in products, increase in reactants. Okay, therefore heat energy must be on the right-hand side. Electrophoresis is exothermic. Okay. That should be fine for that. Okay, calculate the equilibrium concentration given these values. Alright, so what's the expression? Products over reactants, so it's SO3 squared over SO2 squared plus O2. Do we have everything else? Yeah, we do. Alright, so we're looking for SO3. So SO3 concentration will equal the square root of all these things times together. So 8.61 by 10 to the 11 times SO2 0.860 squared times 0.330. All right, good luck on that one. Let's grab the calculator out. Still learning how to use this silly calculator. All right, 0.86 times 0.86 equals times 0.33 equals. Okay, so we've got square root of 8.61 times 10 to the 11 times 0.244068. Okay, we'll times this one by 8.61 times That one's 11 equals, so that's 2.101425 by 10 to the 11. Can we do a square root of that? I don't know. No, we can't. 2.101425 should be enough. Times 11. All right, so we've got 4, 5, 8, 4, 1, 3. So it's 1, 2, 3, 4, 5. 4.58 by 10 to the 5. All right. I don't use calculators, so that's an issue for me. I don't know how much time that took up. All right, what's left? Apply Shatler's principle to explain whether halving the reaction pressure volume at 5 would... Okay, so halving the volume would increase pressure. No escape of particles, no escape of matter. So if we look over here, so we've got the side with the least moles of gas, will be in favor. So products is 2 moles, reactants is 3 moles. Okay, so therefore equilibrium will shift, increasing pressure, will shift to products, that is the right hand side, as only temperature changes the Kc, the value of equilibrium will not change. Okay. Just checking that this is correct. Choose the number of molecules. I said it will shift to be in the favor of least particles. That's still okay. Equilibrium shift towards the product to the left hand side is also said. Equilibrium will not change. Okay. It does say halving the volume doubles the pressure. So that's God mode there. I didn't say halving the volume equal 2 times pressure. Ooh, that's definitely God mode. It's getting really specific. So possibly not get the full marks for that one. Reducing the number of molecules present. I think I still get that other one though. I'm not sure how harsh they're going to be on this one. That's possibly only got 3 out of 4 for that one. All right, so I'm often trying to think of a difficult pH question so that you're ready for the test. And the tests are usually very straightforward, but this test, I think 2022, in my opinion, it is really quite a hard one for this question, and I think the next one as well. So this one here, as you go through it, they're really trying to trick you. You've really got to, the difficulty in a lot of these questions is working out exactly the chemical equation, exactly what's going on. They do scaffold it for you. It'd be fascinating to know what would happen if there was no scaffolding, whether there'd be a single student that could get this one. But this one is a rather difficult one. So let's just get into it. So you've got a weak acid and a strong base, and it's being neutralized. So write the chemical equation out and show the 2 bits. So that should be fine. So we have ethanoic acid. So we need to show Bronsted-Lowry has to be a proton. So Bronsted-Lowry acid is a proton donor. So we have to show protons coming off. All right, so CH3COOH, aqueous, and there was sodium hydroxide present, and that would be aqueous too, and so the CH3 comes off. Na, and that will go to H2O. And so we got aqueous here, now we've got a liquid here. There's a proton donor, which is here. Just say proton donated. It has actually swapped. So the mark scheme actually has this just off rather than one coming off, but I don't think that should matter. And so obviously this must be the Bronsted-Lowry base. Now, because it's to be a Bronsted-Lowry base, I think it is better to go with what do we got here? I would actually go with a minus, and I'll actually get rid of these ones because Bronsted-Lowry base, because it has to go in the reverse direction, so it has to grab onto a H plus. So it looks better here, it looks clearer as a proton acceptor. And it looks better as a proton donor here. I don't think that should be wrong, but I'm just going to play it smart here, and I'm just going to leave. I think that's the best way to write it. There's a few ways you can write these ones because they are spectator ions, really, that I've added or not added. Just check that's balanced, check the states are there, and we should be good with that. Okay, so determine the Kb of the conjugate base of ethanoic acid. So that is the trick. So what we're actually doing now is trying to work out the Kb of the CH3COO minus going to acting as a base. Sorry, so that is H3O, and it's grabbed one. So it is sort of neutralized an acid there. But the Kb's here, and so to get between pKb and Ka, you normally, when you go between hydrogen ion and pH, so the hydrogen ion equals the 10 to the minus pH. So if we have the pKa here, we could do it that way. We could go from pKa to Ka, and then you could do another thing with that, or you can just see what's here. So they have got Kas, they don't have pKs. So I'm going to go with this equation here. So my way of doing this one, so the Ka will equal 10 to the minus pKa. So that is 10 to the minus 4.76, which is just the Ka. So that's 1.7378 by 10 to the minus 5. And so this equation here has the Kw, because K times Kb. And so the Kw will be, so the Kb will be Kw divided by Ka. And so the Kw is like, well, pH plus pOH is adds up to 14. So what that really is, the two of those added together is 10 to the minus 14. So pH 7 in between is 1 by 10 to the minus 7. So 10 to the minus 14 divided by 10 to the minus 4.76 is fine. Okay, so if I do that, So what are we doing here? Divided by... I didn't really need to do the other one. So that is 5.755 by 10 to the minus 10. Now, I should have been able to do this one too. I just didn't need to do that much work. So I'll just do that just to confirm. Okay, so I'm going to watch myself a little bit. Over-analysing these things a little too much. This one's only worth 1 mark. So just to confirm they are the same thing. It's always good to do double checks. So we can be pretty confident with that. And this is a hard question, so it is good to do that at this stage. Okay, just going on to 3C then. So calculate the concentration of the conjugate base at the equivalence point show you're working. Okay, so the conjugate base, that's the equation we need. So that was worth looking at because that's going to save us a little bit of work there. So we can just, we can sort of have a look at that equation. So that's going to take a H, what have I written here? That's a H3O. So that's working as a base, it's accepted a proton, it really splits up water, so it's a H3O, so it's H2O to OH minus. So I actually wrote that wrong, so just double check it. So you got water and it pulls hydrogen and it creates OH minus, okay? So probably should write that one down again. So that's the trick here, like you've got to realize which equation is actually in process here. That's one of the reasons they're tricky and the thing that students struggle with a lot. Now the KB, if you've forgotten, you know that the water's not involved in those ones. So you can just write those out like this. So therefore, I'm just jumping a little bit here. Okay, this is the assumption here. Well, I don't know if it's assumption, it's stoichiometry. So those two are the same. So I'm still going to write them both out. And then, so that's really tricky. I think that would stuff a lot of people up. So we can mix, what can we get out of that? We've got the KB worked out. So if this wasn't scaffolded, just like, oh crap, how do I get the KB? It's quite a lot to think about. They have scaffolded it out, but I still think this is a really hard question. And so we have, what is it? Calculate the concentration of the conjugate base. So we have that as OH minus concentration and the CH3. So how much CH3O is going to be produced? This one seems to be rather nasty. So the amount that's neutralized, I have to do some stoichiometry to sort of work out how much there is. So I don't actually think that is necessary. I've just gone down the rabbit hole. I might have to do that next. Okay, so I'm sort of jumping. The concentration of the conjugate base will be how much was left over here. So I am in the wrong place for the moment. But so I'll just leave this in brackets. So if there was 15 mil, so the number of moles of sodium hydroxide, C equals N, concentration number of moles on volume, so number of moles equals C times V, C times V, and so that is 0.1 times 0.015, so that is 0.0015 moles. All right, now we can do 1 mole NaOH is to 1 mole of conjugate base, CH3COO minus. Therefore, there's 0.0015 moles of CH3COO minus. All right, and this is in 50 plus 15. So that's 0.065 litres. So only tricks here, really. It's kind of deceptive, it's 2 marks. So the concentration, I probably will have to go to here on the next question. So I sort of jumped in way too early for that. C equals N on V. So that is 0.0015 over 0.065. It's a little annoying they leave such a short amount of space, because to do proper working is half a page for this, and they should, I don't know why they do that. Anyone who's doing a good answer is going to be doing it like this, because I know I've used up space there, but that still doesn't make room for the rest of it. So putting that into the calculator, 0.0230. So the concentration is 2 point, that rounds up to 2.3112, okay, by 10 to the minus 2. All right, 2.3 on 10 to the minus 2, and that's the number of moles. All right, so as you can see, it's gotten quite tricky already, and we're going to need some of that stuff over here. So calculate the pH at the equivalence point. So what's going on at that equivalence point? There's no more base, there's no more acid, there is just the conjugate base. And so what we have is, if we go back to here and repeat this stuff here, the pH is going to be this stuff here. So I'm just going to rewrite that stuff. So just trust me, I'm just rewriting this bit. So that's squared, and I've just worked out concentration at other thing, 2.31 by 10 to the minus 2. All right, so that really is the trick, I think. Just you've got to get your head around what the hell's going on. It's not that easy. I was actually quite impressed with how difficult this is, because they don't usually go to that level of complexity. And now I'm back to my own personal issues of trying to get the calculator to work. Okay, so I should be getting good at this by now. All right, so it's okay, so we have 3.64 by 10 to the minus 6. Okay, so that's all the hard work done. The rest of the pH calculations are a lot easier. So pH equals negative log OH concentration. And so hopefully, it's not going to let me do this one, is it? Log. Is there an answer button in here or something? Oh, there is. There's an answer button. All right. Thank you. All right, so that's 5.44. All right. And so that is the pH. So pH equals 14 minus POH. This is to one decimal place. So we can go to 5.4. 14 minus 5.4. So that should be 8.6. Quite a hard one. All right. I'm quite impressed, actually. I don't actually know how to make this one harder. I think they really did a great job on this. All right. Must do question. Okay, so bioethanol using starch and cellulose. We've got starch here. We've got using an enzyme to break it down, and then using another enzyme, and this one's using acid to break it down, and then using another enzyme. Okay. So identify why it's important to control temperature during the fermentation to produce bioethanol. So they're both enzymes. So enzymes have a narrow temperature range. Before being denatured. At high temperature. And then therefore inactive. All right. What else are we looking for here? Fermentation requires use as a catalyst and requires use as temperature sensitive. Enzymes have a narrow temperature range. Temperature sensitive, yes. Requires a catalyst. I didn't say it was yeast. So there's an enzyme here as well. So I'm leaving it at that and not quite sure if I'm going to get the marks for that. So I really should say enzymes. I really should just say the yeast and amylase. I guess they're just going you to know that they are enzymes that are in the yeasts. So just double checking that. So explain why cellulose is harder. Again, this is the scary ones. 3, that's a bit scary too. Explain why cellulose is harder to convert to glucose than starch. Oh no, let's try this one. So cellulose is a linear polymer. Is a linear rigid polymer that has strong hydrogen bonding, therefore little access to enzymes. So the extra acid hydrolysis step to break up the glucose, break up to glucose is high temperature. And not suitable for the next step. So it's a long process. It's not going to be enough. Okay, so you're going to go back in God mode and try and fix that one up. Let me see if it does get there. Identify cellulose as a linear polymer. Ouch, that's actually a mark. All right. Identifies monomers compact closely together. Has strong, therefore little access to enzymes. That sort of says it in probably a better way. What would you call them? Monomers. All right. Explains increased hydrogen bonding between cells and makes hydrolysis of cellulose more difficult. That's implied there and also said in the second question. So it probably does get the 3. There's always an issue with these essay questions. The way that what they're asking for, etc. I don't know. Maybe they should just get rid of essay questions out of chemistry altogether. Clearly, there's enough there to show you fully understand what's going on, and even better than what the mark scheme is. But it's possible you might not even get. So the sample response has beta glucose. Like, does that really matter? It doesn't. I could have said that cellulose requires cellulase, but they didn't use the cellulase. They used an acid step. So, yeah, I'd give that one 3 marks. Never really happy with these short answer questions, to be honest. If they're good enough, they should get the mark, because it's just being silly. It's not really chemistry if you start analysing which word was said. The gist of it is there. There's an understanding there of why that's necessary. Okay, going on to 4C. Now this one, I'd love to know the statistics on this one, because there's no reason to actually know what that is. It's not the syllabus or any of the textbooks. I'm going to go forth and not know what that is, because why would I know what that is? It would be logical to be weight to be grams and volume to be litres. I'll tell you now, it's per 100 mils. It's actually grams per 100 mils. But let's just assume we don't know that, see how we go. I think I spoke to one student that said you can just work it out. I don't know how. But I think if you just use these values and then do a correction to this, because it makes more sense, you can still get there. All right, so that's definitely God mode. All right, so the other thing that's really hard about this question is knowing what the formula is. So they didn't give you the formula, so they assume, because this is stoichiometry now, that you're going to know what the formula for glucose to ethanol is, and that is in the reaction. So you should have memorized it in the synthesis reaction, the topic 2 reaction. So you should have memorized those, or written it in your cheat sheet if you couldn't. So pretty nasty. I really want to know how many people got this one right. It has to be extremely low. It could be one of those 0% ones, like in that Victoria, some of those Victoria, the VCE aTAR chemistry tests. They have a few ones that are like 10% or 0%. So the formula anyway of ethanol, if you have to work it out, well, you just write out the whole formula, and then you're going to convert it obviously to... so this is going to be to ethanol, sorry. So glucose, so you go to your formula book, or if you remember from junior, it's 12.6.12 from biology, believe it or not, is where I teach that, respiration and photosynthesis, which is another reason why I'm not a huge fan of organic chem. So oxygen, I just teach that, what the plants need. Well, it's to go in the opposite direction, and then respiration's in this direction, but this is a slightly different molecule here, plus CO2. Now, the problem is how many of these glucoses. Now, you should have memorized it. So C2H6O is here. It's 2. That's the magic number. Is this actually... No, it's anaerobic respiration, so it's just that. So that's a bit of a trick there. Don't know how many that would have got. Those that were diligent enough to memorize all their fuel synthesis equations. And so now, what are we up to now? So this is the problem here. This is our actual yield. All right, so we've got to work out our theoretical. So let's just assume we had 15 grams per litre. Okay, so we have number of moles per litre. So the number of moles of glucose we got here, number of moles glucose, we'll just glue this mass on molar mass. So we've got to do that as well. That's a little bit rude. What do we got? We've got this one here. So that's 180. All right. So mass of glucose is 15 over 180. All right. So that equals 0.083. So 1 mole glucose is to 2 moles of ethanol. All right. So 0.083 is to x. So x equals 0.083 on 2. 0.0417. Okay. So the number of, let's go down here. Why do they leave us so little room? All right, there's clearly a lot of clear calculations that should be written out, but here we go. So number of moles, so what are we looking for? Yield. So I need the mass. So mass of the ethanol equals number of moles times molar mass. So that's 0.0417 times 46. So that's, oops, that should have been times. Yeah. Should just put lines through these. All right, 0.0833 times 2 equals 0.166. 0.166 times 46. 7.66 grams. So yield equals actual divided by theoretical times 100. So that is, actual was 37.5 grams per litre, and we're thinking the theoretical is 7.66. So that is 37.5 divided by 7.66 equals 489%. And what is this? 1 decimal place? Yeah, that's interesting. 489%, 1 decimal. 489.5%. Now that doesn't make any sense. All right, so this is where you need to go to God mode. So at the current situation, you've only made one mistake, which is here. So there should be error carried forward. You should at least get 2 marks for this. But then you can see this is 48.9, which doesn't make much sense. Usually you'd expect anywhere between, 50 to 100%. So you could be thinking this is actually here. And so you've said that there is not enough by a factor of 10. So maybe it's not grams per litre, maybe it's grams per 100 mils, because that's 100. And therefore it is 150 grams per litre, because you're comparing this in litres. Okay? That's God mode. So then you have to convert that to a 0, and then, bring everything back. So bring everything back here. Bring that back to there. Bring that back to there. Get that to 76. Get that to 76. And that'll be there. And then you've got 48.9. So that will round up to 49.0. 48.9. 955. 48.9. I've actually got 49.0. So there's also a round off error there as well. That's super nasty. And so the answer is 48.9. So I would have to check my calculations there too, because I've done a round off error in there as well. So that's how I think the only way that you could get it when you get to here to sort of reanalyze what these units could possibly be. And the 100 is sort of like makes a little bit of sense too, and those units you should know. Okay, so that one there. Look, we've had like our top math student, I think this was a year or 2 or 3 years ago, in tears because there were 2 complete questions that wasn't just hard, it was completely blank. They left them completely blank, and they still got 100% for math. So it's all on a bell curve. If it's ridiculous, it could be that no one in the entire state gets it correct. So the question gets written off. And you might have got it right and it gets written off anyway, and you still get 100. But you got this question right too, and you still got 100. So that's the deal, yeah? Don't stress out. Do your best. Keep going through. Do all your calculations. If it looks a little crazy at the end, don't stress out. It could actually be written off, or you could end up getting 2 out of 3. So just deal with it. So even those ones where I said I got 2 out of 3, it could be that no one else got higher than 2 out of 3. It depends how, you can never tell. All right. Okay, question 5, one step in the electrolytic refining. So we've got impure anodes and pure cathodes and copper sulfate. Predict whether the concentration of copper sulfate will change. Obviously not. What are we going to do here? So electrolytic. So we're going to have copper cathode, and we're going to have an impure anode. And so we're going to have copper coming out of solution here and then going back into here. That's going to be negative, that's going to be positive. So predict whether the concentration will change. Okay, so how are we going to get 4 marks here? So the copper sulfate concentration will not change because the Cu2 plus that enters the solution is equal to the Cu2 plus that leaves as above. That'll cover us for a lot, help you making use. They can have the diagram too. So they want half equations. So this is the one we want here. So at the anode, we have Cu solid goes to Cu2 plus aqueous plus 2 electrons. And so that is oxidation, and then reduction at the cathode is Cu2 plus 2 electrons goes to Cu solid. All right. So predict whether the concentration of copper sulfate will change in the purifier. Provide appropriate half equations to support your. Okay, so therefore the copper that is oxidized to Cu2 plus is the same rate that Cu2 plus is reduced to Cu. All right, now this is going to be tricky. Like, there's going to be, how are we going to get the 4 marks is the question. What else can I say? I've got half equations to support reasoning. I've said it hasn't changed. I've said there's oxidation reduced. We'll go with that. All right. Where's the mark scheme? Identifies copper ions are reduced to copper metal and cathode reduction half equations. Yeah, I've got that. I've got a copper metal is oxidized copper. Yeah, I've got those too, and I've used the words oxidized and reduced. No change in the copper trace will not change. I said that at the very beginning. Identifies copper ions are reduced to copper, the same rate. Yeah. Okay. That's fair enough. Okay, nothing nasty or silly in that one. That was reasonable. There are 4 reasonable things to say. All right, 5b. If the copper contains zinc and silver and zinc, determine whether each metal could produce this byproduct. Refine, explain your reasoning. So we need to be able to compare them. So I'll just pull them out of here, your data booklet, and I'll just find them. So we're going to have silver and zinc over here. So they've got to be reversed. So the zinc solid will go to the zinc metal and 2 electrons at plus 0.76 volts. And where's the next one? Copper. Yeah, so copper is going to go to Cu2 plus 2 electrons at minus 0.34 volts. And the last one is silver. It's going to go to silver ions at minus 0.80 volts. Okay, so what's going to happen? Could you get the metal out of it? So what's going to happen is this one is going to be preferred. This one's going to be the most. So this is the most preferred to be oxidized. As zinc is preferentially oxidized, it could come out first and be reduced, collected at the cathode. Okay, but if it's in high enough concentrations, because all of this is about rates of reaction. So it's okay, but due to collision theory, and also we also know and electrolysis at low concentrations. This collision theory and electrolysis at low concentrations. Just write that whole word out because I can't read it very well. This is actually unlikely. So that's a really tricky point. All right. This one here, silver will not be. It won't be oxidized, but it will drop out. Will drop out as sludge at the bottom, as leftover metal. All right, 4 marks. I've run out of space. All right, we'll leave it there. We'll see how we go. Marking. Identify silver as less reactive than copper and zinc. Yeah, I've sort of said that. I haven't said reactive though, but it's implied a lot in a lot of these sentences. Deduces silver metal not oxidized, remains as a metal. I said that. Deduces zinc metals oxidized form ions found in solution. I did get that. Okay. Explains zinc ions remain in solution at low concentration but are reduced to zinc metal at the cathode if concentration becomes too high. That one's really a tricky one that I did get. Because it is something we always have to think about with electrolysis and galvanic cells, as well as the voltage, internal resistance. But we've already done that we've seen that in the previous exams, and obviously with halogens as well. That's specifically in your syllabus about the effect of concentration and how that's applied. They're starting to apply that to all the other questions too. Which is a bit of complex, unfamiliar really. Okay, so question 6 here. Polypeptides and proteins formed by condensation. Identify the type of bond when amino acids are joined to form a tripeptide and state the other products formed. So that's just a peptide bond. You just had to know that. Glycosidic bonds, peptide bonds. And so when the carboxylic acid comes out, the NH3, so the OH and the H, one of the H's drop out and the H2O, and it says condensation, and it's the only molecule that forms. So H2O is byproduct. All right, mark scheme, water is formed, byproduct. I should be able to get that. Okay, that should be fine. All right, well, that's an easy one to start with. Okay, determine the total number of tripeptides that can be formed with these ones. Use 3-letter symbols, assuming you have to describe two. What is this? This is hilarious. So if you have histidine, lysine, and glycine, you can have it the other way around. This is, what's this called? Probability and permutations or something. What was this called? I can't remember. It's been too long since I It was in high school math. How on earth does that register as a question? So there's 6 combo. Oh my goodness, 6 tripeptides. Peptides could form. And use 3-letter symbols to describe, so you don't even have to draw it out either. So this is a little crazy. So HIS, LYS, GLY, and then HIS, GLY. Oh my goodness. That's it. That's just okay. So we've gone from super hard questions to ridiculously easy ones. That's 5 marks for that. All right, something a little bit more reasonable. We've got some electrophoresis going on. How could you separate them? So go to your data booklet, isoelectric points for histidine, glycine. So you just have to look those ones up. So histidine 7.6, glycine 6.1, glycine 9.7. So if you're trying to separate them, this one's in the middle. All right. So you can get these other ones to go pos or neg and go in the opposite directions. So use a pH buffer of 7.6. So histidine is a Zwitter ion and electrically neutral. So it won't move. Now, if glycine's normally glycine is in, there will have it's 7.6. So it's normally 6.1, but if you increase the number of OHs, it'll basically have H pluses removed. All right, so if it is in that case, so it will be a negative ion. All right, so in this case, you're going to have histidine here, and you're going to have electricity going through this area here. So this will be the cathode, and then this will be the anode. So the anode will be positive. So the cathode's negative, the anode's positive because it's electrolysis. So glycine will have the hydrogen ion removed, so it'll be a negative ion. So we're going to have glycine over here, and it will move to the positive cathode. Okay, so lysine will be in a, what is it? It's 9.7 environment, more acidic than when it is a Zwitter ion, therefore more H pluses, and be a positive ion and move towards the negative cathode. Should definitely get us the marks for that. This was a pretty easy question, this one. Very easy. And it's worth 8 marks. It's worth a lot. All right, so mark scheme explains where buffer solutions histidine is neutral and not migrate. Got that. Glycine's negative and goes to the anode. Glycine's negative. Ooh, move to the positive. Ooh, I said cathode. Oops, I meant anode. Oops. I wrote it all there. Doesn't make sense. Ouch. I think I might lose a mark for that. I wasn't watching when I was writing. All right, so that looks like I got 2 out of 3. Ooh, nasty. All right, lysine forms a positive, more acidic environment. Positive ion moves toward the negative cathode. Oh my God, what a disaster. Disaster has struck. All right, so just got to be careful. Don't know whether explaining and writing and everything at the same time is making me lose my concentration. Possibly. I'll blame it on that. So I've still got heaps of time, maybe half an hour at least. So if you get rid of all the talking and stuff I've done in the gaps and stuff, and I just did the question, I was just focused on the question instead of trying to explain everything all the time. Hopefully wouldn't make those sort of mistakes in a half an hour. Is plenty of time to go through everything and read it and check calculations and stuff. And so hopefully you'll get full marks for that, doing it that way. All right, best of luck.